In this video, you'll learn how to analyze series, parallel, and combination circuits. We'll start with series circuits. Here we have a series circuit connected to two resistors. In a series circuit, there is only one path, so the current is the same throughout the circuit. The current through the battery is the same as the current through resistor 1 and resistor 2. The voltage across the battery is equal to the sum of the voltage across resistor 1 and resistor 2. The total resistance, also called equivalent resistance, is equal to the sum of the resistance in the resistors. Since there is only one path in a series circuit, if one resistor or component is removed, then all the other components go out because there is now a gap in the circuit. Now we'll analyze a series circuit mathematically using the VIRP chart. The V stands for voltage and is measured in volts. The I stands for current and is measured in amperes. The R stands for resistance and is measured in ohms. The P stands for power and is measured in watts. This circuit has a 1 ohm resistor and a 2 ohm resistor connected in series. The first thing we'll do is calculate the equivalent resistance by adding their resistance. 1 ohm plus 2 ohm equals 3 ohms. Then we'll use Ohm's law to calculate the current through the battery, which is equal to the voltage of the battery divided by the total resistance. And we have 6 volts divided by 3 ohms, which is equal to 2 amperes. Since this is a series circuit, the current through each of the resistors will also be 2 amperes. So everything in the current column should be the same. To find the voltage of each resistor, we'll use Ohm's law again. V equals IR. So 2 times 1 equals 2, and 2 times 2 equals 4. To find the power, we use power is equal to current times voltage, or P equals IV. So we have 6 times 2 is 12, 2 times 2 is 4, 4 times 2 is 8. Notice that 4 plus 8 equals 12. Power is energy transformed per unit time, so it makes sense that the sum of the power of each resistor equals the power output of the total circuit. Next, we'll look at parallel circuits. In a parallel circuit, there are multiple paths. The current through the battery is split between the branches. So IB is equal to I1 plus I2. The voltage across the battery is equal to the voltage across both resistors in parallel, since each resistor is connected to both ends of the battery. To find the equivalent resistance for parallel, we use the equation 1 over Rp is equal to 1 over R1 plus 1 over R2. In a parallel circuit, if one resistor or component is removed, the other components will stay on. Now we'll complete a VIRP chart for a parallel circuit. In this circuit, we have a 6 ohm and a 3 ohm resistor connected in parallel. We'll start by using our equivalent resistance equation. 1 over Rp equals 1 over R1 plus 1 over R2. So we have 1 over 6 plus 1 over 3 is equal to 3 over 6. Since we're looking for Rp, not 1 over Rp, we have to take the inverse of 3 over 6, which is 6 over 3, which is equal to 2 ohms. Next, we'll calculate the current through the battery using Ohm's law. 6 volts divided by 2 ohms equals 3 amperes. Since this is a parallel circuit, the voltage across each of the resistors will have the same voltage as the battery, which is 6 volts. Then using I equals V over R, we can get the current through the resistors. 6 over 6 is 1, 6 over 3 is 2. Notice that the current through the branches, 1 and 2 amperes, equals the current through the battery, 3 amps. Using P equals IV, we can calculate power. 6 times 3 is 18, 6 times 1 is 6, 6 times 2 is 12. Notice that 6 plus 12 equals 18. Next, we'll look at combination circuits. In a combination circuit, we have both series and parallel components. Our strategy here is to simplify the circuit. We'll do this first by finding the equivalent resistance, then use the series and parallel circuit characteristics to find voltage and current. Here's our first combination circuit. We'll first combine the 2 ohm and 4 ohm resistors in series by adding their resistance, which would get 6 ohms. Then combine the 6 ohm and 6 ohm resistors in parallel. After you add the fractions, don't forget to take the inverse, and here we get 3 ohms. To get the current through the battery, we'll use I equals V over R, which we get 6 over 3 equals 2 amperes. Since the 6 ohm resistor is in parallel with the battery, it also has the same voltage as the battery, which is 6 volts. We'll calculate its current using I equals V over R. 6 over 6 equals 1. Since there are 2 amps going through the battery and 1 amp going through the 6 ohm resistor, there must be 1 amp going through the other branch. Then using V equals IR, we can calculate the voltage across the 2 and 4 ohm resistor. And finally, we'll calculate the power using P equals IV. When we add up the power for each resistor, 2, 4, and 6, we get 12, which is the total power of the circuit. Here's our second combination circuit. We'll first combine the 2 ohm resistors in parallel. 1 over 2 plus 1 over 2 equals 1. We'll take the inverse, which we still get 1 ohm. Then we'll combine it to the other 1 ohm resistor and get 2 ohms. We'll calculate the current through the battery by using I equals V over R. We get 6 over 2 is equal to 3. Since the battery is in series with the 1 ohm resistor, that resistor will also have a current of 3 amps. Using V equals I times R, we can calculate its voltage, which is 3 volts. As you go around the circuit, the voltage needs to add up to the voltage across the battery. So the voltage across the parallel branches must be 3 volts. Using I equals V over R, we can find the current through the parallel resistors. Then calculate power using P equals IV, and once again, the sum of the power for each of the resistors equals the power output of the whole circuit.